Carl Sagan. Well, what's new in space, Carl?
Think of a civilization on a different planet evolved under quite different circumstances than here. What is their art like, their music, information? Think of how we'd be.
Good speed, guys, good speed. Someone telling us where to stop?
This is the largest space telescope humanity has ever conceived of. We've never done anything this audacious in space before. We have 1,000 people working on this project right now. If it works, it's going to see deeper into space than any other telescope in history.
This is the largest mission, non-human spaceflight that NASA's ever done.
It looks at areas that the Hubble could never see.
The James Webb Space Telescope certainly is the most complex telescope anyone's ever built.
This is a chance to measure myself against one of the hardest problems man has set himself the goal to do.
This is the huge eye in the sky. It's going to capture the very first light of the universe.
We're going to test it. We're going to pack it up in a rocket, shoot it out, and we don't know what we're going to find. But the slightest thing that could go wrong could actually mean this mission could fail.
You've loved astronomy since you were a kid, right?
Yeah, I got into it as a child. My dad won a cottage in a crap game. The attraction of going down there and having these light pollution-free skies and just seeing the summer Milky Way, the odd satellite. And I was old enough to be around when Neil Armstrong set foot on the moon.
That had a big impression on you?
Yeah, that whole space race and the fact that we stepped on another planet, that we left this Earth and all that, yeah, it left a huge impression on me.
How do you think the seeing will be tonight?
It's supposed to clear up later. I don't know if the transparency is going to get any better. Hopefully we can see something.
I think everyone is intrigued by astronomy because it's about the big questions. Where did we come from? How did the universe begin? Are we alone? An amazing thing right now is that we're on the verge of really being able to answer these questions. It's an exciting time.
Fascination is still mind-boggling. You're involved now with looking for extraterrestrial intelligence, right? With a committee. How do you go about looking?
Why do children learn how to walk? I don't know. I mean, they just do. They're driven somehow by a force inside of them that they can't identify. I don't know why I'm doing this. I just feel compelled to go forward. When I was a small child, I went with my dad on a camping trip. It was his first and last camping trip, but fortunately, he made it happen. And I remember waking up in the middle of the night and stepping outside the tent. And I looked up, and it was my first ever view of a truly dark sky. And I saw so many stars. I went, wow. I had never imagined that was possible. I couldn't even count them, and they were so bright. And a little later, my father took me to a star party. And I remember looking at the moon through a telescope, and I went, wow, I couldn't believe that the moon that I had seen so many times actually had craters on it. I saw it in an unbelievable amount of detail. I just didn't know it existed. And at some point I realized, I don't know how I had the foresight at a young age, but I thought, I'm not going to study physics. I'm not going to be a doctor like my father wanted me to be. I'm going to apply for graduate school in astronomy. Great.
Fernando.
Wow, I didn't even realize it was this
And we're going to move it into the dark room.
Started out working on exoplanets.
You mean not Jupiter, Venus, Mars, etc.?
Yes, planets orbiting a star other than our sun. What's so cool is you can build your own space satellite. At the time, people really didn't think that was a good idea. People would come up to me and say, you can talk to my advisor. He thinks exoplanets are nothing. You shouldn't be doing this. He'll tell you. Professors would say, look, I see people are finding planets. I kind of believe them, but we'll never be able to study their atmospheres. And when I was on the job market as a junior faculty, there was one single transiting planet known, HD 209458b. And they'd say, look, Sarah, I get there's this one object. I think it's a one object, one method success. I don't know if this field's going to go anywhere.
The Webb telescope is 100 times more powerful than Hubble. When telescopes keep getting bigger because the bigger the telescope and the better the resolution. You know, we wouldn't have built a telescope this big unless we needed to, and you need to build a telescope this big if you want to look at the very dimmest, most earliest galaxies in the universe.
The James Webb Space Telescope is not just a machine built by engineers and scientists to look out at the universe. It's taking humanity on a journey. We're going to enter a completely new part of observational space where we've never trod before. And every time we've done this as a species, we've discovered new things.
We have just received the 18 hexagons that make up the big mirror that collects the starlight and focuses in on the camera.
Gold has very unique properties in terms of reflecting infrared light, and this is an infrared telescope. So that's why we choose gold.
I think people want us to build this telescope because they want to know how we got here. I want to know how we got here.
You know, we started the James Webb Telescope to look at the cosmos and the early universe. But we've discovered it's so much more powerful that it can do new things. And we're seeing teams of people, led by women, taking that scientific direction somewhere else. Taking it to try and understand, could there possibly be life out there?
Do you have any estimate for how many nights you spent up at the Crocker Dome?
Oh my gosh, between 2000 and 2003, we spent so many nights up here. And it's quite remote, right?
I mean, that's the thing, there's no bathroom,
Right.
there's no internet.
There were so many creatures along this path.
When I started in the late 1990s, we were trying to find planets using this small telescope up at Lick Observatory. We were using this new technique. It had never been done before, and people were very skeptical. In fact, the whole thing was built on a shoestring budget. But it was so compelling to work on a project that had the possibility of detecting an Earth-like planet in the future.
But I do remember this pathway.
Yeah.
Is it possible to get in?
You know, unfortunately, I don't have the key right now, so
all of the
repair
instruments
inside.
have been taken out,
Yeah,
right?
there's nothing in there. It's just some empty shelves.
This is not the astronomer's ideal weather conditions.
Isn't this a way to understand why we had to go to space?
You know, to find planets, you need to stare unblinkingly. So besides the fact that the sun gets in our way sometimes, we have day, the weather does too. So no observations are going to be done tonight.
You spent a lot of years up here at Lick looking for exoplanets. Did you find any?
We found hundreds of periodic dimmings of light, but none of them turned out to be bona fide planets. The analogy I like to use is to imagine a skyscraper 80 stories high in New York City, and you've got all of these windows, and it's nighttime. All the windows are illuminated. And one person goes to one window and lowers the blinds by about 1 centimeter. That's the change in brightness we had to be able to detect.
In the beginning, it was a lonely field. Very few planets were known. Months would go by and not a new planet would be discovered. Nevertheless, I knew the field would explode. And I'd say, look, I know there's going to be so many planets transiting, we're not going to be able to count them all. And they'd be, no, I don't believe it. And so they didn't believe it, they didn't hire me. And then came Kepler.
3, 2, 1, 0, and liftoff of the Delta II rocket with Kepler on a search for planets like our own.
Chamber pressures are building.
The Kepler Space Telescope monitored one small section of the sky, and it found thousands of planets. Another Earth is undoubtedly out there. In our own Milky Way galaxy, we have hundreds of billions of stars. Our own universe has hundreds of billions of galaxies. To me, personally, it is definitely there.
No power for you. This one? Oh, there you are. There you are.
Good morning, everyone. Sorry I'm late.
Hey, Natalie. We have a good group in the room today.
All right. Well, the last few meetings, we've had one planet candidate in each batch.
Yeah.
We rely on a few core experts. Natalie's one of them.
Natalie was one of the leaders of the Kepler mission.
Kepler was so pioneering, it opened our eyes for the first time. And TESS is now just finding objects around closer stars and smaller stars as well.
Okay, the low synchronous transit.
How are you detecting these exoplanets?
Well, nowadays, the best way to find planets is by the transit technique. If this represents our star, and this blue represents a planet, if you're lucky, the planet will orbit such that it passes in front of the star, as seen from the telescope. Then the starlight drops by a tiny amount. Thousands of planets have been detected this way. They range from smaller than Earth size to Jupiter size.
So Eileen showed me this one yesterday.
I like this one. Look how long the transit duration is, too.
Yeah, this one's also past century offstar.
We're hoping to find and identify a pool of transiting planets in the habitable zones of small stars.
Makes sense.
Let's keep it.
Not too hot, not too cold, but just right for life. The Goldilocks zone.
On to the next one.
The next one looks great. One system that had two viable planet candidates that were very exciting.
Yeah.
It was super.
So you want to study these candidates with the James Webb Space Telescope?
Actually, the question often comes up, how much time are we going to get for exoplanets? You know, if we find a rocky planet with a thin atmosphere in the habitable zone of an M-star, do you have any idea how much telescope time we're going to need to look at that planet's atmosphere?
We have 5 more to go, 6.
Yeah. Let's kill it.
Given that our own atmosphere contains thousands of gases, we expect alien atmospheres to also contain thousands of gases. And my job is to figure out how each one of those gases interacts with light. And some molecules, like oxygen, we send out into space, life does, but other things do too. Some molecules, like phosphine, only life sends out into the atmosphere. And so it's one of the reasons I'm so fond of it, because although it's rare and actually quite poisonous, only life makes it on Earth. And so it's an unequivocal sign of life.
I mean, there's more energy on the target.
My generation, we're betting on the fact that nature delivers, that life can originate and evolve anywhere given the chance. And we're planning on finding it. There's no question.
You know, at some point you build a telescope that's too big to fit in a rocket, and James Webb would not fit in a rocket. So we had to make the primary mirror into individual segments. It's been done on the ground once or twice, but doing it in space is a whole nother set of challenges.
Is it going to hold? Is it going to keep its strength? Is it going to keep its alignment? Will it deploy?
This is a worldwide telescope. It's the collective investment from the U.S. and the European Space Agency, the Canadian Space Agency, that all these countries are willing to make to reach the edge of the universe.
Separating from the upper stage, separating, we're going to L2.
The stakes are tremendous. If you think back to Mars Science Lab Curiosity, the 7 minutes of terror waiting for it to get to the surface, we were all holding our breaths. I didn't hold it for 7 minutes, but I held it for a long time, waiting for that signal back from the surface. In this case, we're going to hold our breaths for a couple of weeks, because that's how long it's going to take to get all those deployments out after launch.
Adding whatever delta V we need.
There are over 300 or 400 different operations that have to occur in space to make this telescope actually come to life. A huge sunshade has to deploy, which is the size of a tennis court. At this point, things get pretty critical, because now everything starts to cool quickly.
Solar array for maximum power.
So now we've got to get the telescope unfolded before it gets too cold and the joints freeze up. Then got to get the instruments started. And each one of these things has to work perfectly first time.
Hello.
Hi, how are you?
Good.
So about the James Webb, what's new? What's the latest going on?
It's very exciting. Lots of things. The spacecraft structure is moving along like gangbusters. We're making the flight membranes. Pathfinder is delivered. So basically, it's almost all the balls are in the air at this point.
Sometimes we hear rumors of something that's not going so well. Is there anything like that that you're worried about, you personally, or is it all under control?
There are always little problems, nothing insurmountable.
Yeah.
The thing that keeps me up at night and prevents my hair from growing back is the problem we haven't thought of, that failure of imagination. Right now we're on schedule and making flight hardware.
Well, it's so great to hear that, because the entire science community, in exoplanets is ramping up here. Everybody's so excited about the James Webb, but I don't know if you realize how much they're counting on this.
I'm aware that my customers are very anxious for the Webb Telescope to get on orbit.
Yeah, it's pressure, but it's also gratefulness that all you and your team and people are working so hard to make sure every last thing works.
Okay.
Okay,
great.
bye.
Bye-bye.
Good, huh? It's a great conversation. He's like basically the brains behind the whole thing, and sometimes I don't ask him this time, but almost every time I ask him, like, well, what if something bad happens to you and you get hit by a bus? Who's the next guy?
There's a couple of race series that got started in the last 5 years or so. My husband and I, you go on Craigslist, look for a really cheap car, and then you drag it home and you fix it up, you race it. Being a system engineer for the Webb Telescope, I don't really get to touch a lot of this hardware. So working on cars is pretty satisfying because it lets you actually put your hands on something. I'm not strong enough.
Those races are 14 or 15 hours long, and usually we break down before we get to 14 or 15 hours. And James Webb, it's a very different problem, and James Webb has to work first time.
It is too far away from the Earth. Where we're putting the Webb Telescope is a place called L2. And if you think of, here's the Earth, here's the sun, L2 is on the other side, a million miles away from the Earth. The full moon is between us and L2. That's where James Webb will be. It's 4 times the distance to the moon.
Oh my God, look at that picture over there. Hand me a roll of color quick. Oh man, that's great. Where is it? Quick. I'm looking for one. That one? Oh, here. Hey, I got it right here. I got it right. Oh, that's a beautiful shot. You got it?
50 years ago, they say, we went looking for the moon, and we found the Earth.
Yeah,
Right?
that's true. That picture of the Earth, that was really the beginning of the modern environmental movement right there. One of my favorite little lakes. There's an eagle circling around in front of us. In grad school, I asked the question, what does the Earth look like from very far away when you can't see the continents and the oceans? And can you actually tell that there is life on that planet? So we looked at the moon. Not too many days after new moon, when you can just first start to see that thinnest crescent right at sunset, you'll notice that the dark part of the moon is also visible because the Earth is shining on that part of the lunar surface. So if you take a telescope and you look at that light, it's Earth light, all jumbled up together. It's the land, it's the ocean, it's the clouds, the air. And when you spread that light out and look at it, you can plainly see the squiggly line that this is a planet that has a definite clear oxygen line. And there's definitely carbon dioxide and there's methane. Those signals were all tangled up together in the colors of the Earth. And that was what we called the spectrum of a habitable planet. When I first heard of the search for extraterrestrial intelligence, I thought that this was by far the most interesting thing to study in all of astronomy. Finding out that there are other civilizations in the observable universe would be pretty much right there at the top of things you could find out.
You're working with Jill Tarter in the SETI Institute.
Yeah, absolutely. Jill was the SETI pioneer, the search for extraterrestrial intelligence. I met her shortly after the movie Contact came out, and I had never heard of Jill before. I didn't know there was a connection between that movie and her.
Yeah, the Jodie Foster character is modeled on her.
Yeah, Jill is one of my longest mentors.
When we started, SETI was considered pretty fringy. We didn't even know if there were any planets beyond our solar system. And we spent a lot of time building up credibility, making a distinction between ourselves and the folks who report seeing little green men in spaceships and being abducted. I mean, people would be writing books about the SETI pioneers, and it would be, what's a nice girl like you doing in a place like this, sort of questions. It was really hard.
Do you think there is life out there?
You know, Nathaniel, whatever I think about life beyond Earth doesn't matter a bit. Now, for millennia, we asked the priests, the philosophers, whoever we thought was wise, what we should believe. Well, we can now change that verb into the verb to explore. Anything else is religion, and we're not doing religion here, we're doing science.
What's going on with this one?
The birds love to nest here, and they will chew on this, and they will chew through it. These dishes pick up radio frequencies, and we're listening for broadcast signals from a distant civilization. We're looking for signals that are engineered, things that Mother Nature can't do, but we can, and presumably they can.
But we have looked a bit, and so far we haven't found anything.
We just haven't looked far enough. That volume of search space, set it equal to the volume of all the Earth's oceans, and then ask yourself, how much of the Earth's oceans have we searched? And the answer is 1 8-ounce glass. Now, if your question was not, are there extraterrestrials, but are there fish in the ocean, and you did that experiment and you dipped your glass in and you looked at it and no fish in there. I mean, that experiment could have worked, but there aren't any fish in there. I don't think that you're going to conclude there are no fish in the ocean. You're going to say, I got to fish a whole lot more. And that's where we are. We have a lot more searching to do.
Ultimately, science is about observation, because it's only observation which actually gives you the truth. As the ancients looked up at the sky, it was obvious that everything went around us. We were the center of that universe. And then Galileo lifted his telescope to the stars. He looks at the moon. The moon was supposed to be this perfect orb. And he sees for the first time the moon is not perfect. It has mountains, it has craters. But the most important observation, the one that was truly revolutionary, he looked at Jupiter. And he saw 4 pinpricks of light, and he assumed they were stars. And then he realized they were moons going around Jupiter. Everything was supposed to be going around the Earth. And here was proof it wasn't. And he realizes that the ancients were wrong, the church was wrong, and we're going around the sun. Observation overthrew ancient wisdom.
This was the very first time anybody took 2 lenses and lifted them to the sky and revealed a universe that nobody had ever seen before.
Once he'd done this, and he wrote it down, you can see it in this book here, he wrote down what he saw. Other people could build their own telescope, and suddenly these ideas could actually flood out. Well, Galileo was locked away for 10 years because the church claimed that this wasn't true. 400 years ago, it started there. 400 years later, we're actually taking a mirror, which is 250 times roughly bigger than this. We're going to fold it up and launch it into space to give it even more sensitivity to actually see to the edge of the known universe.
Wow, traffic is crappy. I think everybody can agree we're wasting a lot of energy and effort here. There's a lot of people around, and we are not being as responsible as we can with everything that we have. Actually, when I grew up in Taiwan, in Taipei, it has some of the worst pollution. Oh, it was hard to see the stars.
With all our problems on the Earth, should we really be spending so much money on a telescope?
Our almost reason for being, one of our reasons for being is so that we can do these good and interesting things that move us forward as a species. I think everybody wants to do something, be a part of something greater than just what they can do alone. Building something like the Webb Telescope is that. So, I don't know, what else would you want to do with your life?
Hey, John.
Good
to see you again.
Hi, Amy.
Amy,
Hi,
pleased to
nice
meet
to
you. We've never met before. I'm sorry, I didn't
Yeah,
mean
no
to
worries.
ignore you. John and
It's
I have known
okay.
each other for a long time, so you
John's got a big present.
grabbed my attention when I saw him.
So, you've come a long way.
And your timing's perfect. We're just about to run a test.
This has got to work like all the other major elements. We have enough sensitivity with our telescope and our instruments to detect a child's nightlight located on the moon. I know that if you were to certainly take your radiant heat, which for a human is about 80 to 100 watts, and stick it on the moon, we would easily be able to detect that.
When people think about the telescope, they think of the huge mirror, right? That's the iconic part of the telescope. But this is what the astronomers care about. This is where the data comes from.
Our telescope is so sensitive that it could pick up the heat of a bumblebee if the bumblebee were as far away as the moon. That is completely astonishing to me, even knowing that that's our telescope and we built it that way.
Yes, I've heard that. In fact, I was asked about it. I'd have to sit down and do the math very, very carefully. I've learned one does not argue with Nobel Prize winners.
I heard about this calculation. I checked it myself. I believe it's correct. Yeah.
If we had the moon here and the Earth, 250,000 miles. What we need to do first is calculate the area of this frequency times Planck's constant, 1 joule per second. That frequency is also related to 10 to 20 per second.
A bumblebee gives off how much energy?
Well, let's see, it gives off about 50 milliwatts of power.
It does seem reasonable that we could see a bumblebee on the moon with our telescope. That's a bumblebee as opposed to a yellow jacket, as opposed to a hornet, but we could collect the light. Should know better than to argue with our chief scientist.
These are all worker bees, which are female. There will typically be some drones in here too, bigger males. They aren't essential to the survival of the hives.
The males are not essentials.
No. In the fall, all the drones are going to get kicked out. They're going to be begging to stay, and the workers are going to be like, sorry, we do not have resources to feed you all winter. They're going to kick them out, and they will go freeze and die. And these girls will stay together all winter long, beating their wings and making enough heat.
I'm living in Wisconsin because I really wanted to be closer to the natural world in my daily life in a way that an office couldn't do for me personally.
It reminds me of the shape of the mirror from the James Webb Space Telescope.
It does, yeah. The hexagons are just a really efficient way of packing together a bunch of cells in one place. So that is a shape you will find in nature and in mechanical engineering. I already know which of these hives isn't going to make it through the winter. It's hard on them. There is colony collapse because of chemicals that's going on field. There's a farm field right there. That's obviously not being sprayed. The bees probably love that. And they need diversity of resources. It's fascinating to see how that social structure operates, and one does kind of wonder, is there another civilization of that type out there that is more collectively minded than we are? If there are other civilizations, that could be really useful information, because we're at this point where we don't know if we can survive the emergence of technology.
If you think it would happen, when would it happen? Within a period of 10 years, 20, 50 years?
See, it depends on how much of an effort we make.
We are one step closer to answering the age-old question, are we alone in the universe? NASA announced the discovery of 7 Earth-sized planets around a star about 40 light years away from Earth.
This is the latest revelation in a wave of discoveries over the past 25 years of new worlds that exist in solar systems beyond our own.
Astronomers call the discovery the TRAPPIST-1 system. Sarah Seeger of MIT is one of the researchers.
We've made a giant accelerated leap forward in the search for habitable worlds.
These planets are among the best of all the planets we know to follow up with the James Webb Space Telescope. The discovery gives us a hint that finding a second Earth is not just a matter of if, but when.
Wow, TRAPPIST-1 is all over the news. I mean, look at it. Nothing else comes close.
Yeah. And look at the TESS predictions. I mean, even the simulated sample from TESS doesn't reach down there. I mean, TRAPPIST, I think, unless we get extraordinarily lucky, TRAPPIST is going to remain this singular system, completely unique.
TRAPPIST is just so cool, especially if some of those planets
could have water features. All right, we'll pick this up later.
Okay.
You can leave that.
It's nice that my daughter is actually involved with this, so I do feel like I'm passing something on.
I am designing the observing program that we're going to use with the James Webb Space Telescope to observe TRAPPIST-1e.
And 1E is what? That's one of the planets?
Yes. The TRAPPIST star is much redder and only about half the temperature of our own sun. B and C are probably far too hot to be able to sustain surface liquid water. The habitable zone, which is also sometimes called the Goldilocks zone, is right about here. And E really sits right in this region where surface liquid water could potentially exist, which is what we think we need for life. And I can actually show you this in a travel poster. And so here you can actually see what you would be seeing if you were sitting on the surface of TRAPPIST-1e.
Well, how do you mean a travel poster? Where did this come from? What is this?
So this is an artist rendering of TRAPPIST-1e. It says, voted best hab zone vacation within 12 parsecs of Earth.
And below it, does it describe it at all?
It says, some 40 light years from Earth, a planet called TRAPPIST-1e offers heart-stopping view. Brilliant objects in a red sky, looming like larger and smaller versions of our own moon.
You're part of a team, right, that's doing this?
Right. So when James Webb is launching, we will be able to measure the atmospheric composition of some of these planets.
So tell me, how did you come to study exoplanets? And
when I was really little, probably 8 or 9, my mom had me and all my siblings draw pictures of astronauts. And I was so proud to show her, and she looks at it and she goes, oh yeah, that's awesome. Why did you draw a white man? My mom is a female scientist, my dad is a Latin scientist, and I had drawn this white man, and I was so shocked. And I think moving forward, I was always conscious about that. And instead of being some, being something that kind of discouraged me, I think that kind of empowered me.
We all have the same desires and wants, and journalist science and NASA missions brings those things to the table. Unfortunately, in the space science community, it hasn't been as diverse as it should be. One of the things with exoplanets, it's newer. Generally, the newer science attract more diverse teams. So yes, that really excites me. And we're scientists and engineers, right? So certainly we follow the data. All of the data supports that teams are far more successful and better when they're more diverse. So I always say now's the time, and I think now's the time.
Nothing? Okay, let's get started. Any questions, guys?
24 more to go, time.
We don't want the telescope portion of the Webb telescope to see any of the sun, is because we're trying to keep it very, very cold. In order to detect heat signature, infrared signature, it obviously needs to be very cold, or all it's going to measure is just itself.
Okay, -J mid, MTS full deployment, layer 1.
In space, really the only thing that'll heat you up is the electronics that you've got and the really bright source, which is the sun. And that's the purpose of the sun shield. The sun shield keeps the telescope from getting all that sunlight, so it stays cold.
Nice and slow, guys. Nice and slow.
What's particularly challenging is the fact that we have to fold it up and deploy it once we get on orbit.
Stop. Hold that.
What happened?
You just lost the cable.
Oh,
you can talk to Johnny about that?
Yeah, you know, I'm gonna go get him while we're doing layer 4. And
okay.
I'll come back with him for layer 5.
Yeah, let's do this. Brian, are you ready?
Ready.
You ready?
Yeah.
We don't have the big one. Going up?
Layer 1's running about 212 degrees Fahrenheit, and layer 5 on the cold side is running about -400 degrees Fahrenheit, so it's approximately 1,000,000 SPF.
I'll tell you what, you go and you try and pooch that up, you're not going to come anywhere close.
If you look at it, look, it's just
That's
about
what I
off.
need somebody to explain to me, and how that's going to be okay on flight. I've always set my sights on big goals. I'm a very competitive person by nature.
Nice.
I don't like to lose. I like to prove myself equal to any challenge.
America's first attempt to launch a satellite.
I was a little boy. My father told stories.
This was checked out by scientists.
He worked on Vanguard, and it blew up on national television. Just blew up twice.
Give me one more. Here you go. Done, 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 done.
By the time I'm done, I will have been on the program 12 and a half years. And it will all come down to that very short period of time between launch and when we complete deployment, about here. It's not unlike training for a meet. I would train for months for what literally was a few seconds of activity. We're all very well aware that we have to get this right the first time, the only time, because out at L2, repairman doesn't make a house call. We don't get that second chance. It's a once.
Sometimes I put music on, like 80s music typically, and just let my mind wander to like what's out there.
What's your favorite music?
I just kind of like the 80s. What about you?
Oh yeah, well that's my era too.
The 80s is big now, you know? Even my kids know all the 80s songs. Lots of kids do.
Really?
Apparently, yeah. Apparently the 80s, the beat is still very popular. Interesting, right?
Yeah, that's interesting. What keeps you, where does the drive come from?
I mean, the drive is really the end goal, which is finding another Earth, the true Earth.
Mm-hmm.
But that's the drive, right? But the joy is in the everyday.
And if we could find another Earth, what do you think that would mean for us?
Yeah, it's a tough one. What do you think it would mean? Well, I don't know. I feel like I have to ask you and everyone else what it would mean.
Yeah.
I mean, it would mean that we're not alone. It would mean that we're not the center of the universe, and it would really expand our horizons as to what's out there and who might be out there, as well as who we are.
Who we are, yeah. What's that?
So this axis here has to point to Polaris, basically. And
Polaris is the North Star?
Yeah, North Star. Now the cameras. So this is a one-shot color.
What do you think about, finding another Earth? And all
Yeah,
this
I understand the drive. I understand the curiosity and the journey of discovery and the importance of discovery. And that will change things if we do find another world that has biosignatures or evidence of life on it. But we have life here. And we have love here. And everything that matters to us, or really then is important to us, is right here on this Earth. And that's what's important, to me. Yeah, that should be good enough.
You actually found the love of your life through astronomy, at an astronomy meeting.
Our eyes met at the wine and cheese reception before her talk, and I was just wondering who this person was, and I didn't know she was the keynote speaker. And then the next day, she gave another talk just before lunch. And after that, I decided, which was probably the most important decision I made in my life, was to be healthy, and I decided to get a soup and a salad. And I walked into the lineup, there's a bit of a line, and she turned around, and I asked her, would you like to join me for lunch? And she said yes, and we got a table off to the side by ourselves, and 5 minutes into that conversation, I knew my life was going to change. I knew something was going to happen.
Don't let me interrupt you from continuing the telescope.
Okay, let's get back at this thing, and we'll see what we can. Go
back if you want to try to see if you find a way to do a program. But the first thing is just get the measurement once every. But
I don't really know why anyone wants to know why there's life out there.
Step ladder.
I guess because we're kind of a lonely species.
Should have been up here then.
I think loneliness is a human condition. Everyone's sort of trapped in their own head, and we try with our lives in various ways to be not lonely. We find friends, partners, mates, family, we have children. We're trying to find life elsewhere because we have a need and a desire to communicate and to connect in any way possible.
Ready? Okay, Brian. Ready.
Okay, we'll try this again.
Layer 5 on 3, 2, 1.
10 inches of travel, 20 inches of travel, 30 inches of travel, 65 inches of travel, 80 inches of travel, 190 inches of travel, 197, 198, fully deployed.
There.
Wow, that's good, huh? I want to go see.
This is hundreds of man-years of work. I don't think it's possible to overstate how exciting this is. It's another step, just like completing the backplane and completing the mirrors. I'm gonna have a hard time concentrating when I take Mom to dinner tonight.
Yeah, how's that?
Wow. Wow, it looks good.
It looks fantastic.
All right, imagine you are the telescope.
Wow.
Looking out on the universe, looking out on the stars. Because it's going to be dark and cold out there where this is. Imagine yourself frozen.
It has no company out there in orbit. It's all by itself. We see life on another planet. I mean, we have to motivate to go say hello.
Oh, no.
I mean, it's just, that's it. They're there, we're here.
just animals. Everything in this whole museum is basically animals, even the tiny ones, but this is just a tiny fraction of biodiversity. This kind of complexity doesn't happen easily.
How did it happen? Did it happen here?
Some people think life started on the land. I think it started down at the bottom of the ocean, in hydrothermal vents down across the seafloor. The one that most people know about is a really dynamic system called black smokers. They were amazing because nobody expected to see so much life down there. Weird forms of life, giant tube worms that don't have a mouth or an anus, and enormous clams the size of dinner plates. And oceans.
A worm that has neither mouth nor anus?
Yeah.
How does it eat?
It doesn't eat. I mean, it basically uses the bacteria that grow inside it to provide it with organic molecules. Well, there's another kind of vent, which I personally think is the answer. I like to think of them as Gothic cathedrals. Beautiful architecture in the rock. They're actually formed by a much more gentle process. Water will percolate down beneath the ocean floor. And there's a particular type of mineral. It's called olivine. You find it as dust throughout interstellar space. This is a really common mineral. And the thing is, it will react with water, bubbling hydrogen gas out. And that's basically the environment that's giving rise to life.
Do you think that there's life out there beyond the Earth?
I think we hope that there's going to be lots of amazing, complex life out there, kind of semi-human in the way that it interacts with us. And I think we're likely to be quite disappointed about that. You know, maybe we should be interacting with life on our own planet in a more meaningful way.
How far can you push a planet in one direction or the other and still have it capable of sustaining life? During graduate school, I would walk from the astronomy department down to family student housing. We were studying comparative planetology, and my head was full of these images of Mercury, Mars, Venus, even the moon, all of these lifeless worlds. And so walking from the department, you come up a knoll and you all of a sudden emerge from the redwood forest, open up onto this big meadow. But you're up high. So you see it as this very thin veneer of life stretched out before you. It looked like I could just reach out and wipe it away with a sponge, you know, like cleaning the kitchen counter. And I just had that feeling that the difference between a living world and a lifeless world was small. Tiny difference, like an accident, you know?
It's been a rough spring start, but we had a lot of heavy snow in February. I mean, a lot. It was like every other day it would snow about 10 to 12 inches. And the disasters are getting worse and they're getting stronger. And there's so many people who don't, they're like, this is how it is.
You mean climate change deniers?
Well, like, there's more fires, there's more earthquakes, they're happening more frequently, there's more tornadoes.
It's like a couple blocks away, there's big trees that are down, roots up.
And there's another cell coming that it looks just as bad as last night. It's bad. And there it is.
There's another storm coming, yeah.
Yet another one. We're battening up the hatches. Hi, I'm just leaving the farmer's market. Could you look at the radar and plan what to do with the bees?
We're on the blue dot, and it's moving in our direction. It looks pretty bad.
The latest climate data that broke last week proved that the whole environmental movement is a power grab. The global alarmists are a cult.
Thanks for being open amidst the storms here. So this is beautiful.
We can put it together for you.
It's been a while since I've been shooting, and I really miss it.
They used to shoot
to do it again.
Before, didn't you?
Yeah, I've been writing proposals to the federal government to fund my teams to fly space missions and look for life on other planets. And
yeah, have you found it yet?
No, but we're getting ever closer.
Do you believe there's life out there?
I feel like, how can there not be? This one planet is so full of it. It's hard to imagine how that could happen here so richly, and then everywhere else in the whole universe is just a sterile rock. Surely life arises when the conditions are right.
It's an interesting topic.
Yeah.
I started listening to some podcasts. I know he's very controversial, but like I was listening to one with Alex Jones, and some of the stuff he talks about is like really, really interesting. If there is other life forms, you know, not just human or aliens or it could be plants or anything, you know, just something else out there besides our Earth.
In San Francisco is the main project site. Literally have an alien base, and they are literally communicating, and they've got like astronaut level people taking super hardcore levels of drugs and going into meetings with these things and making intergalactic deals.
You didn't actually think you were the only inhabited planet in the universe.
I'm from SETI, Search for Extraterrestrial Intelligence.
So if the aliens get here, are they going to wipe us out?
Well, I think that if they can get here, that means that their technology is significantly in advance of ours. So they're older than we are. And how did they get to be old? Because they outgrew all of the aggression that was probably part of their evolution to become intelligent. We show many different indications that we won't make it, that we will, in fact, do ourselves in before we become an old technological civilization. So if they can get here, I'm more inclined to talk with them rather than worry about them eating me for breakfast.
I was sent last night a link to an old Johnny Carson show from the late 70s with Carl Sagan.
Having here, he is a professor of astronomy and space sciences at Cornell, director of the Laboratory for Planetary Study. Would you welcome, please, Dr. Carl Sagan?
Is just about reaching the Trappist system.
You're looking for extraterrestrial intelligence, right? How do you go about looking?
It's a little like this. If you're an advanced civilization and you wish to communicate to a backward civilization, you talk slow and simple.
And obviously we would be the backward civilization because we do not have that capability.
To what?
Now people are going to ask you, what is the value?
We are at a very dangerous moment in human history. We are in the process of inadvertently altering our climate and all kinds of problems which come with technology. We are not certain that we will be able to survive this period of what I like to call technological adolescence. But were we to receive a message from somewhere else, it would show that it's possible to survive this kind of period.
Now, wouldn't that be something? In other words, somebody has solved a particular problem we are still wrestling with.
It's good to know that the problem could be solved. I think it would be very, very useful for ourselves.
We going to find them in your lifetime?
I don't know how long I'm going to live. I know we're going to try and look.
We keep trying.
We do keep trying.
The James Webb Telescope will achieve its mission, but we have to go through all of the engineering and all of the checkouts to make sure that that is indeed a fact.
Eventually, we'll go all the way through the Panama Canal to French Guiana, where the Europeans have their launch site, and they're providing the rocket, and the telescope will go up from there 1 million miles out into space and get ready to work.
This is where we're going to test the telescope and its detectors in a space-like environment. Chamber A was originally built for the Apollo program to test the command module with the astronauts in it. We're here building on the legacy that the country built in the 60s.
Ladies and gentlemen, with Mr. Webb, director of the space program.
Ladies and gentlemen, the National
James Webb was the administrator early on in NASA's life. During the early stages of the Apollo program, working with Kennedy to establish that program to get us up to landing on the moon. It was that commitment to science that he had. Now, we still have a bunch of environmental testing that we have to do, vibration testing and acoustics testing, because what we want to do is make sure now it survives the rocket launch, which is still the most violent environment that we see.
We bring it in here,
the sun shield in its stowed cocoon state. We subject this to the sound noise of the rocket. Because when the rocket launches, it doesn't just vibrate, it also hits you with sound waves. And it pushes on you with pressure. And we need to prove that our vehicle will survive that. So we hit this thing, what's called proto-flight acoustic test levels, and we run it across a frequency spectrum. We found a screw and a nut. We had a few dozen that actually separated in this test, because there's 1,000 of these little screws. No, there's probably a lot of people on high floors of buildings waiting to hear that Webb has made it today. We're kind of one of the, say, more humbling points in the career when you know you have to go tell people that test wasn't successful.
The Subcommittee on Space will now come to order. Today's hearing will focus on the serious issues associated with the James Webb Space Telescope.
When we integrated the spacecraft element and did testing, we made all kinds of discoveries that were unfortunate, and not just unfortunate, problematic.
Although I've heard testimony how important it is, I understand that. It's very frustrating to me and other taxpayers that this is so much of a cost overrun.
Every screw has to have its quality tested. I can tell you this is about the biggest screw job I've ever seen, and it's the taxpayers getting screwed here.
We want to make these mistakes here on Earth, because that mistake, if it was in space, it would be too late. It can't be fixed.
Once we install it, it's there for the rest of the mission. So we got to get it right the first time.
And then it gets ready to go?
It's still got a lot more testing. That assembly can withstand launch.
Now all I have to do is live to see it go.
Well, you got to make it till your grandchildren get out of college.
Yeah,
and that will happen after we launch.
That's true.
What do you think about when you contemplate our cousins and our ancestors?
Mortality.
Well, as a species.
Yeah. Well, I mean, it's more and more clear that, looking at these skulls, that there have been numerous human species, and they've all gone extinct apart from us, usually because of us, usually after interbreeding with us. Do you feel some guilt when you look into those eye sockets? I do. Why? Because we know about this history. There's some guilt in human history in the way that we've dealt with other human species. Our own history, dealing different racial history and so on. We need to learn. How do we bring the best side out in our own societies? We're within touching distance of at least finding out. And the idea that we might find life is an exciting one. Though, what do we expect to see out there? If it's not nothing, the overwhelming likelihood is it's bacteria. And if we see somehow that we've got way beyond bacteria to large, complex life, that means this. It means microscopic life. It means tiny animals. It's a wealth of life, and yet somehow I think most people would be disappointed if all they found was microscopic sludge.
Would you be disappointed?
No, I think I would be astonished to find that. To find anything more than bacteria, I would be astonished. Perhaps part of the point of looking out there for life is to realize just how valuable the life is that we have here.
Physically, evolution made us, biology made us, but the things of biology were created in stars. The water, the carbon, the nitrogen, the oxygen, all of that was created in stars. People will say, well, if there are 10 to the 22 stars out there, there must be more life than just us. However, it turns out the number of coincidences that have to occur for life to emerge is also a very large number. We have to have a star, like our sun, that lives at least 10 billion years old. It has to be in exactly the right part of the galaxy to start with. We might need to have a moon. We might need to have geothermal, because we need a magnetic field to protect us. And then things of evolution had to happen. And then you keep on going, and well, you know, the dinosaurs evolved, and they were around for, I don't know, 100, 200 million years. Nothing happened. They didn't evolve into anything. They got bigger and bigger and bigger, and then the meteor came and wiped them all out. And then these small, warm-blooded animals evolved to us. But that was an accident. How many accidents need to happen for intelligent life to form? We just don't know, because we only have us, one example. It might only be 1 part in 10 to the 22 that life emerged. So we could actually be alone.
You know, I had all these accomplishments. I became a professor, and then I got married. I had like the perfect husband, the perfect kids, and the perfect house. I had everything. And I had such a great life. And then my husband got sick and he died. And so after that, what do? What do you do next? Like, you can't return to your everyday existence and just like cook dinner, which I never did and I still don't, but I'm just trying to think that you can relate to. Like, you know, I just can't explain it, but the everyday normal things you do, they're just meaningless. I went to my book club and the women were complaining about their husbands, like who's gonna pick up the kid? And I'm like, give me a break. You know, I just couldn't live with normal people anymore. I realized that whatever I was gonna do next would be impactful. Why waste time? Out of all my accomplishments in life, helping my husband have a death, like a perfect death, was probably my biggest one. It was really sad when he, it's sort of funny but sad, but I told him before he died his death would have meaning and that, you know. I'm trying to describe it in a way that will be funny, but it's too hard. Well, just give me a second, because I really want to tell you. It's really funny. It was like, Mike, you know, your death has meaning. I'm going to do big things, because I've realized it's, you know, things that matter. And he just, it was funny, because he could barely talk. Like, if you know anyone who's dying, they're not able to communicate. And he just looks at me, he goes, Sarah, you would have done it anyway. That was one of our last conversations. It's not that I have to find the Earth and name it after him. It's more of the search for meaning, and how to live a meaningful life and how to do something that actually makes a difference. That's his legacy. I have to have meaning. I have to do something that has some importance as seen by myself, because otherwise I have nothing. Does that make sense?
So can I just be really blunt with you? While I understand there's a longer story arc to this very complicated and very expensive mission that has been delayed yet again.
It's all right.
But I can shoot bullseyes all day, and then as soon as somebody comes along and says, oh, you're doing really well, it's over. No, I won't hit a thing. At some point, the only thing that can save you would be somebody high level in the administration who just says, we're devoting the resources. And Congress would have to back that up. If you're gonna do something, just do it right.
Yeah, see, that's good.
Yeah, so that's
good.
More accurate and precise. We only have not only just one precious planet, it's this time the specific time of now where we have to live.
What are you tasting? What are you tasting? Tasting something?
It's taking the salt off my fingers right now. I hope, for the sake of all of us, I hope that JW just gets off the ground, flies, and does well at everything that it does and performs all of its objectives.
Hey.
Hello. So it sounds like we should stick with TRAPPIST-1E and then look at this plan in detail and make sure that we have it finalized.
This is our observation plan, you mean?
Yeah.
It's going to be a really good test of the telescope itself.
Yeah. I'd be really interested to understand, if they are tidally locked, like the moon, what that means for having a permanent day and a permanent night side.
There would be some people who would constantly be living in daylight and then other people who would be constantly living in darkness.
Right. I mean, the best place to be on these planets would probably be perpetual twilight, right? Right around the edge.
Right at the limb.
And what that would be like, because living in the Arctic and you living through perpetual twilight, it's a very strange experience.
Do we know what the temperature differences would be?
As long as there's air. Air is very good. They have substantial atmospheres.
My favorite thing about TRAPPIST is that if you're on the surface of one of the planets, you can see the other planets resolved in the sky.
Yeah, bigger than the moon, right?
It would never have been a question of, is the Earth the center of the universe? I mean, it's crazy to think that TRAPPIST being 39 light years away means that they can hear what we were doing on the radio and television 39 years ago. The first years of Reagan, Madonna. What do you think they'd think about us? Do you think they would think that we're going in the right direction?
Interesting question.
Yeah.
I like that one.
Well, so if they're monitoring our culture, they're also monitoring any sort of atmospheric signals as well, right?
Yeah.
So they're probably watching, our carbon dioxide emissions in all of this and probably thinking,
what are they doing down there?
Just for planning purposes.
I want my kids to be able to swim in the ocean, climb mountains, be in nature.
Even if there was an inhabitable planet, we're just going to ruin it like we're ruining this one.
This is an emergency. Our house is on fire. We deserve a safe future, and we demand a safe future. Is that really too much to ask?
Hello. Nice to meet you.
Nice to meet you. It's a pleasure to have you here.
Thank you so much. It does.
But this is the place that he was under.
He was under house arrest for starting a revolution that people didn't want started.
They were afraid of it.
They were afraid of what he saw, and they were afraid of the fact that he used observation to upturn ancient wisdoms. It isn't just that we're trying to do amazing things with telescopes and look for other planets. I mean, our generation, my children, are facing real challenges on this planet. How do we tackle these global problems which actually will affect our own survival as a species? It's going to take a collective endeavor with the type of groups we're putting together around the James Webb. These are collaborative groups. These are people who want to work together. It gives me hope that we can change the way we operate in the world, change the way we do science, using data to say, look what is happening, and not just going back and saying, I don't want to hear, or I don't want to see. Well, you know, they said to Galileo, I don't want to hear, I don't want to see. And yes, they sequestered him here for the last 10 years of his life. But here we are, 400 years later. And we all know about Galileo, and we have to look up in our history books to remember who the Pope was that actually put him away. We remember Galileo. I mean, Carl Sagan said it best. It's going to take us centuries to get to the stars as a species. And it's going to have to be a better version of ourselves to actually get that far on this planet.
Good morning and welcome to the second day of the hearing entitled James Webb Space Telescope, Program Breach and Its Implications.
We've had a lot of discussion about cost, and the cost matters. But I will tell you, taxpayers and all of us are way more concerned about value than cost at the end of the day.
James Webb should continue based on its extraordinary scientific potential and critical role in maintaining U.S. leadership in astronomy and astrophysics. Let's finish this incredibly important project.
Inspiring and challenging projects such as the James Webb Space Telescope are an investment in our future. We must not lose sight of the importance of bringing the James Webb Space Telescope to a successful outcome.
All right, see ya.
See ya. Have a good day.
I will.
So this is like the biggest day of your career in a way, isn't it?
It's pretty big. Been working 7 years towards this day, so yeah. This is going to be now the James Webb Observatory. Before, you know, it was like this piece or that piece, but now it's actually all together, one piece. Hello. You can see the way it's going to look when it's operating, so. Yeah, it's kind of a big deal. Everyone's really excited. The entire team's kind of vibrating a little. Ready?
I'm not allowed to follow you. This is goodbye, I guess. Good luck.
See you in a bit. Come on. Dennis, I can't get in. Thank you. See y'all.
You know, Amy's worked with me since she joined the company, and I wanted her taking over alignments because it requires attention to detail and people skills and innate genius that's necessary to do it. And today is the culmination as we see the system go together, but it's got to go together precisely, and it's got to end up where it's supposed to be. And that's the job to which she's been devoted for these last 7 years. Every piece of hardware, 500 odd pieces of ground support equipment, have a story, have a team that's been devoted. So when I mean an act of collective genius, I mean it.
Many people have spent a big chunk of their careers developing this system, done a tremendous job, and they're ready to go. And I'm ready to go. It's just in our DNA to explore. So as far as we send satellites out, I think we should be willing to send humans out, but we have to learn how to do it. It takes putting our minds and heads together around a common goal, and I think we can do anything. And human spaceflight is always pretty special. But Webb is certainly in the same category as human spaceflight in my mind. So this is my capstone. The Webb is my capstone.
You know, I'm moving. So cleaning out my garage, I found this old binder paper that's from high school. And the theme was the American frontier. You have to remember this was the 80s, so the backdrop of this was the space shuttle program. And so I titled this speech, "Would You Go?" The year is 2010. America has just begun the settlement of a new state. But where is this state? On a distant planet where only a few have ventured before.
And it's called Would You Go?
It's called Would You Go, with a question mark and everything. Yes.
So would you?
Well, here's the thing. My current adult thinking is that as important as exploration is, love is probably even more so.
What about you, Natasha? Would you go?
I don't know. I think I would have to take my posse, all the people that I love with me. I wouldn't be able. It wouldn't be a thing that I would do alone. I would have to take my crew. You know.
What about you, Ellie? Would you go?
You know, it's a good question. I waffle on it all the time. Going to Mars, you know, it's tempting. Yeah. But still, I'd miss nature in the way we have it here on Earth.
For whatever reason, there's this thing, I don't know if this is true or not, but you know, if you meet someone within 2 years of when your husband died, like 2 years is some kind of magic number, I don't know why. And I was thinking, you know, my 2 years are basically up, so I guess it didn't work for me, right? So just before my 2-year anniversary, I was going to Canada. I'd been invited to give a keynote talk. So I go to the opening reception, I see this guy across the room, and I'm like, wow, who's that guy? I have to meet him. And after my talk, I go to the cafeteria a little bit late, and there he is in the cafeteria, and he's with only one other person. And he's like, oh, do you want to have lunch? I'm like, sure. So we go and sit down for lunch, and I'm thinking to myself, wow, I can't believe I finally get to talk to this guy. I left to go home, and then we Skyped. In the very beginning, and it was like, I don't know what to do with this because it's far away. And then I'm thinking, you know, this is good for me. I can crush on a guy. I can just shut the computer if I don't feel like talking to him, if it gets too personal. In January, he was going to London for work, and he's like, Sarah, I'm going a few days early. I hope you'll join me. I want to invite you. And I wasn't sure what to do, but okay, of course I'm going to go, right? So I go to London, and I'm like, wow, I don't know. Are we boyfriend, girlfriend? I'm not really sure. I'm just like, oh my God, like, when am I going to get my first kiss here? You know, here I'm like a grown-up here. This is ridiculous, right? After dinner one night, he takes me on a walk. It's like raining, because you know in London it's always miserable. And there we are in front of Buckingham Palace, and I got my first kiss. And after that, it felt like the romance of the millennium.
Time is a very funny thing, and particularly the disconnect between human time, geological time, and cosmic time, right? We don't interface very well with those longer time scales. And thinking about the far future is really difficult. But if we're going to have a long future, we've got to outgrow all the kind of aggressive tendencies and think about what kind of a place that would be, where people actually valued all life and took care of themselves, one another.
The hardest place is when you have to just watch it all come to fruition. It's like when your kid finally gets on the field and is swinging the bat. You got to sit there and be a good parent. Sure, Amy will be a good parent out there.
I'm wondering if Amy had them go check something, because she's staring up at something.
Yeah.
start getting everything in position and we'll keep moving.
Then we should come down.
All right, guys, keep down. Here we go. Down. I gotta go down.
Look at the guy pins.
Stop.
It's just magic. It's just magic.
Be awfully interesting to look at another place and say, oh, there's signatures of life there. It may not be conclusive evidence, but it sure would get people very, very excited.
Do you think there's life out there?
Yeah, I think there's life out there. Can we find them? I think we will in my lifetime. God, I hope so. Because I want to know, you know?
Charles,
Oh, hi, Sarah.
how'd it go?
Well, I've set up the telescope, and I'm just waiting for it to get dark enough to do an alignment. And
It looks great.
yeah. And
So
hopefully,
what's up tonight?
well, as soon as it gets a bit darker, maybe we'll look at some galaxies. I don't think Jupiter and any of the planets are going to be up till later tonight.
Okay. Did you see any
you don't-
stars yet?
Not yet, but patiently waiting for at least Polaris to poke out.
Right.
But maybe we can discover some exoplanets.
Hey, there's fish jumping out there.
There it is.
Wow, that's really pretty.
Yeah, the Whirlpool Galaxy M51, one of my summer favorites.
It's amazing that we can see it with this telescope.
Yeah.
And just how vast. Like, that's so huge, that scale.
Yeah. We are tiny, aren't we?
Really tiny. Maybe there's a planet around a star there, looking back there.
Our spiral galaxy. Yeah.
Maybe there are two people like us.
Yeah, maybe. It's wonderful to be able to wonder about the universe together with you.
It really is.
Fly me to the moon and let me play among the stars. Let me see what spring is like on Jupiter and Mars. In other words, hold my hand. In other words, darling, kiss me. Fill my heart with song. Let me sing